you haven't used your slider in your CAS, probably worthwhile because that allows you to explore. What I do on Desmos is what you can do on your CAS. Okay, so if you type the same equation on your CAS, it should ask for adding sliders, and you can move the A's and B's or the parameters. So the example could be something like, where's my Desmos? Desmos, here we go. You can actually type in your calculator when you open up the page. You can do y equals, I don't know, m times x plus c. And in my case, it says add slider. In yours, it'll also say add slider. So if I went to something like this, and I just do add doc, add a graph, and I said m times x plus c, it asks you to create the slider in the same form. You can explore the family of curves. That's what 10G is about, family of curves, as you change the parameter m. So if you change m, moving from right to left, you can see it changes the gradient. Okay? And then same with C. C determines the y-intercept, so you can change x and y-intercept. So as you're doing, that's what I'm understanding is the examiners at the end of the year is trying to design questions that gets you to explore the functions they have. So they'll put in more parameters. You need to get a bit more familiar with using Desmos version on your CAS. Okay? And that's probably good for you when you're doing the SAC as well, just to think about how does the function change as you change the parameters. So in this exercise here, what we're doing today, it's called family of curves, and it really is just getting you to figure out, okay, so the shape doesn't change, but by changing A and B's, what will happen to each one? That's why it's called a family of curve, right? Take this example, and these are some of the examples that you could be working with. Given f of x is ax cubed plus bx squared plus cx, we don't know what a, b, and c's are. That's your parameter. But if we did know a, b's, and c's, then we have a particular graph. Now, there are many, many possible values for a, b's, and c's. So they have to give you a piece of information for you to figure out a, b's, and c's for that particular context. So here, they've given you some information. They said that has a stationary point at x equals 1. What does that already imply? If I tell you that something has a stationary point at x equals 1, what am I really telling you?
f dash of 1 is equal to 0.
Yeah. Okay, and what it's trying to say is that if you found the derivative, so f dash of x, find the derivative of your function. We know the stationary points occur when f dash of x equals 0. Therefore, at x equals 1, my derivative should be 0. Okay? So that's the first piece of information they've given you. So that's point 1. Then they also gave you a second piece of information. Because clearly you've got A, B's, and C's to figure out. Likely you'll need multiple equations. They told you f of 1 equals to 6. F of 1 equals to 6 means that when x is 1, y coordinate has to be 6. So here we go. Let's sub it in. So f of 1 equals to 6 means that you got what? That 6 is equal to a times 1 cubed plus b times 1 squared plus c times 1. That should just give you a plus b plus c is equal to 6. Whereas the second one tells me that the derivative, which is that means that f dash, that means 0 is equal to 3a times 1 squared plus 2b times 1 plus c. Thinking feels like there's a problem here. There are too many unknowns. Either they're missing another piece of information.
Is it 0? Is it intercepted 0? Because there's no...
Yeah, but yes.
So
Put 0 in as well. F of 0.
0, 0.
Does it say it intercepts at 0?
Well,
Because
it's got
there's
no.
no plus b.
Oh. Wait, no, say that again.
There's no constant on the end, so it has to be accepted 0, 0.
That's true, because if you factorize that, that would have been the hidden one. That's true. f of x is equal to x bracket ax squared plus bx plus c. That's one of the possible answers for the y-intercept. That's true. Sneaky, sneaky. All right. Well, in that case, now we've got our 3 points and you've got your 3 equations. I've taken up too much space there, but simultaneous equations. Probably use your CAS at this point, or you can do it by hand. Find out A, B, and C. So, what do we have? We've got, let's go, 6 equals to A plus B plus C, and the other one was 0 is equal to 3A plus 2B plus C. And we've also got wait, C equal to 0? No, C doesn't equal to 0. You only got f of 0 equals 0. Does that help? Yeah, that's true.
If you divide both sides by x, you're just giving 0 equals c.
No, you still don't. I don't think. Can you solve this problem?
I think it's possible.
What am I missing?
You just find this A in terms of C, and then just subbing a value for C.
You could find A in terms of C.
A in terms of C.
Yeah.
And
Then you make up a possible value. Yeah. So they might have, maybe this question was trying to get us to use a parameter possible answer, meaning that there is not one specific answer, but usually they use lambda as the symbol to denote. So in this case here, you're probably going to get a value in terms of a parameter. Oh, I actually thought this was designed to get you a number. Looks like they don't. So in this case, just like what Dante said, you'll probably have to say something like, let C equal to lambda, and then everything else now that you're solving for, it's in terms of lambda. Does it? Which question did I get this from? I can't remember where I...
Okay, tell them.
So find A and B in terms of
Alright, the first event is the first 50 deal with and then we come in, Miss Friend Simone, and then we play some 50
It was like a sticking out his cheeks.
Find the value on that and say,
No, he's in public. You're allowed to
B has an answer because they have to give you an America.
No, that's it. I literally said that. I know. As long as you're public.
Looks like my question wasn't complete. For me to ask you to find A, B, and C, wouldn't have been possible without the third piece of information. The example in your question broke it up into 2 bits. You had to find A, B, and C. And the last bit was then give you a third point. Sorry, team. I need to edit my notes on that one. This one's missing. Which example is that from the textbook? 32. That's example 32 of your textbook, 10G. It's missing the third piece of information. So part B of the question actually tells you stationary point occurs at x equals 2. And so that's how you work it out. But part A of the question wants you to find A in terms of A and B in terms of C. So you would have to make it a parameter. But it would be impossible to solve with 3 unknowns and only 2 pieces of information. Sorry, it was the example that I did not copy completely. My bad. Have a look at that. That's example 32. If you're not following what I just said there, we can't solve that, even having 0, 0. Let's hope my next one doesn't have that same issue. All right, example 2. Consider the family of functions with rules. We've got x minus 1 squared times x minus b, where b is greater than 1. I guess on a visual aspect, that means that you've got a cubic, positive cubic where it touches at 1, and it crosses, so it touches at 1, but b has to be greater than 1, so it's probably something like that. Okay, so it has a turning point at x equals 1, and then since b is greater than 1 and it's minus b, it must mean it has to be somewhere further than 1. It's a positive cubic. Because I know when you do a squared on a linear factor, it's a turning point. And it was either two things. It either crosses through something and then it's a turning point at 1. But if it crosses through something and it's turning point at 1, that means that value is smaller than like since they said b is greater than 1, that means it can only cross like without expansion. That's what I did. All right. Let's go. Let's find the derivative team. Use product rule. Derivative?
Yeah.
So I just did bu dash plus uv dash. Then what I did in the next step was I noticed that they both have x minus 1 as a common factor. So I took out x minus 1 as a common factor. Leaves me with 2 x minus b, which is here. And then I need another factor of x minus 1. To make that x minus 1 squared. Conveniently, this one can be simplified, so expand the brackets. 2x minus 2b plus x minus 1. 3x minus 2b minus 1. Is that what you meant by expanding? Okay. Right.
Wait, I fully expanded. Would that still get me a mark?
Yeah. I think it's just usually I find that these kind of, like when it's nicely factorized in that sense, it's probably better. I might even keep it here just to see what the next questions are like if I was to do it in an exam. Yeah. Because sometimes the variations that you have, sometimes more beneficial for the next questions. So you'd have to read the next questions to see if it's worthwhile. All right, part B. Find the coordinates of the stationary points of the graph. Now we know stationary points occur when the derivative equals 0. So you're saying, solve this. So this means that I think not expanding it completely is better, because if you expanded it completely, solving when it equals 0 makes it harder. But if you keep it in their brackets, this probably was much more ideal. Thanks, team. Solving for part B, because they asked you for coordinates, it's not just the x coordinates, you need the y coordinates as well. X should equal to what? What do we have for x? 1? Yes, more than 2. Well, I don't know about this one, but yes. 3x minus 2b minus 1. We can already see that x will equal to, moving 1 across, so that's 1 plus 2b all over 3. Have I skipped too many steps there, or are you all right? I'll let that equal to 0. And I move the 1, move the 2b, and then divide both sides by... I'm going to do it slowly. 3x minus 2b minus 1 is equal to 0. 3x is equal to 1 plus 2b, and then x equals 1 plus 2b on 3. Does that make sense? I'm using null factor law, that something times something equals 0 means one of them has to be 0. That's how we got x equals 1, and that's how we got x equals 1 plus 2b on 3. To find the y coordinates, when x is 1, how do you find the y coordinates? Slide it back in. So f of 1, we can already see it's going to be 0, which we knew from the rough sketch that I drew on the side there. Turning point clearly is at 1, 0. And the next one is when x is 1 plus 2b over 3, I'm probably just going to call it f of 1 plus 2b over 3. I probably won't. Unless you have a calculator, you can probably sub that in to figure it out. It looks too nasty to just work with. Let me use a cas to see what it actually ends up being. Define f of x is equal to x minus 1 squared times x minus b. What does that give us? All right, well, that's a nice, not too bad. That's -4 bracket b minus 1 cubed all over 27. Let's see. How do you know that there's always a local maximum at 1, 0? How do we know that? Yeah. So there's a couple of ways you can talk about the repeated factor. So being at x minus 1, being a quadratic factor, that there must be a local maximum since b is greater than 1. So you can explain it through that way, or you can use, for those who do special, double derivatives, and you can prove at that point if it's positive local max. Yeah. So multiple ways you can choose. So you can use double derivative, or you can describe the x minus 1 squared repeated factor given b is greater than 1. Because you would have had two scenarios. You could either have it crossing and repeated factor at 1, or repeated factor at 1 crossing through b. But we knew it was a positive cubic graph, so there's two ways to explain it. And finally, D, find the value of b if the stationary points occur where x equals 1 and x equals 4. We already know this is your second one. This is where x equals 1. This is x equals 4, so that must mean 4 is equal to 1 plus 2b on 3. And you can solve that equation because there's two stationary points. We already know the first one's at 1, 0, so the second one must be at x equals 4. Since we know the x coordinate of the second one is 1 plus 2b over 3, then we can say 4 is equal to 1 plus 2b over 3. 12 is equal to 1 plus 2b. 11 is equal to 2b, and therefore b must be 11 on 2. So far, so good? All right. What I'm doing in these examples, just to give you a feeling of what 10G is. 10G is just revisiting. Thanks, boys. It's just revisiting your calculus skills in Chapter 9. You've learnt your tangents, you learnt your normals, you learnt how to read a derivative graph. You've learnt maximum problems, absolute, min, and max as well. This one is just exploring, well, what if you have parameters? How do you work with them as well? That's pretty much what 10G is. The next example is a good one, but I'm just sort of wanting to jump to Newton's method. This one is the same idea. I'll write up the solutions afterwards, but it's got a bit of transformation. It's not really. It's just like 3 different questions in one question, but I'll do that example. I'll write in the solutions afterwards. What I want you to do, though, is Newton's method. Can I get a show of hands who've heard or seen Newton's method last year? Just so that I know if you know what it is. 1, 2, 3. And the majority haven't seen or heard of Newton's method. Is that right? Okay. This is as simple as it is. I'm going to give you, so on your sheet, there is a Desmos one that I created. You can type that into your web browser just to explore, but I'm going to do it with you. Otherwise, if you go into the document on OneNote, you can also click on the link yourself as well. But this is what Newton's method is. There's a formula. That one is usually in the end of year exam formula sheet as well, but it's worthwhile you knowing what that is. Because usually if they do a Newton's method, it is a pseudocode version, and your job is to read the pseudocode. Okay? This is how Newton's method works. It's pretty nice. I'm going to show you what the theory is. I created it a while ago. Where is it? I think I left it over here. All right. So you type in that link, you'll get to this one and you can explore it. But this is a simple idea of what Newton's method is. Let's say I gave you x squared minus 2. That's what the graph looks like. So it crosses, it's a graph that shifts down by 2. So your turning point is at 0, 2, right? Let's say I want to find the x-intercepts on the right-hand side. So we know that the x-intercept right now is somewhere greater than 1, but less than 2, right? This is what Newton's method proposes. Newton's method proposes, at first, in your notes, it's a recursive approximation. So you're going to approximate where the x-intercepts are, okay, by doing this. You first pick using a tangent line. You're going to pick a random point. So the random point I picked, to sort of guide you, was I picked at x equals 4 on the curve. So on the curve right now at x equals 4, so I pick a point. So in this question here I said, let's pick a point randomly. And I started off by picking the point 4. Okay, so I'm saying, here's a curve. We know the x-intercept somewhere here. Pick a random point first. So number 1, pick an x value. I picked number 4. Okay, so I said, let's go find 4. So this is part number 1. Step number 1, pick a random number. So start off with a certain number, so x0. I picked x0 to be 4. Okay. Part 2, find the y value to that. So f of 4 gave me 14, right? Now that I've got 4 and 14, I can find the tangent line equation on your CAS. So here we go. Let's go to our CAS. Let's remind ourselves how to find the tangent line again. You go to Menu, Calculus, Tangent line, number 9. I'm doing the tangent line of x squared minus 2 at x equals 4. That's my equation. 8x minus 18. That's my tangent line. Okay? So now I know this is 8x minus 18. That's the equation of the tangent line. Where does that tangent line touch the x-axis? That's the x-axis intercept, right? So now in the graph, I actually did it for you on Desmos. It actually shows that the x-intercept of that tangent line is at x equals 2.25. Right? So let's see in the table. Let's see what I've done. I found the equation was 8x minus 18. I found out the x-intercept is at 2.25, but you could have worked it out by letting y equal to 0. 18 equals 8x and x equals 18 on 8. Same thing, right? What's Newton's method? Repeat that. So what was my 2 steps? Step 1, pick a point. Step 2, find the equation of the tangent line to tell you what the x-intercept is. Now, how do you repeat that process? This new x-intercept, x equals 2.25, is your new point. Then you find a tangent line at 2.25. And you do the same thing again. Find the equation of that tangent line. Where does it touch? The x-axis. That gives you a new point. Find the tangent line again at that point. And wherever the x-axis intercept touches again, you get closer and closer to the actual x-axis intercept. But the question is, when do you stop? How do you know when to stop? You don't. This is why when I asked you before, why do we find that y value? Is because what do you expect as the y values, as the x-axis intercept the tangent line, as it gets closer and closer, what are you expecting the y values to end up being? Closer to 0. So you should get approximation. It should be 0.000 something, Right now it's at 14. So when I first started, when you write it out, it should be, when it's 4, it's 14. Okay? My gradient at that point was 8. Okay? But what I'm interested in, as I keep doing this iteration, and this formula, what is Newton's method formula? It is to find the x-intercept at each point that you do. So you can just recursively type in the numbers. So you do x1, x2, and you type in this formula, it will give you the x-intercept of the next one. Okay, so that's what I pretty much did in Desmos in order to find that x-axis intercept that you're seeing on this graph. So if I go back to the Desmos, let's play around with it. Here we go. So you got the idea. Here's my first tangent line. X-axis intercept is 2.25. So now I'm going to change A. So instead of that new point, I'm now going to change it to 2.25. So here we go. 2.25. There's my new tangent line at 2.25. And here's my new x-intercept. What's my new y value? 3.0625. So it went from 14 down to 3.0625. So let's fill it in. Here we go. So this is now at 2.25. The y value is 3.0625. And the gradient, which I didn't have a formula to, I didn't write it in. I guess we can ignore that for now. You can type it in if you, I haven't figured it out, the formula for it yet. But it should be somewhere here. It's probably that one there. Yeah. All right, so you got 1.56944, so that means 1.56944. You do it again. That's my new one now. 1.56944, so then I sub in the new one. 1.56944. I get now a new x value and a new y value. What is that? That's pretty close. There, isn't it? That's 1.42 now. 1.42189.
So what's the point of this?
The point is an approximation. Yeah, I know, but what they're trying to teach you is there are some graphs that you can't just figure out the x-axis intercept. So then, like algebraically. So when you can't do it, you can approximate roughly. Now there's two methods. There's Newton's method and there's the bisection method as well. That's an approximation. So if you can put in a calculator and you tell them to repeatedly do that repetition, that's how they spit out an approximation for you. Because they do this repetitive recursiveness.
So in the exam, it's not as like manually.
No, so in the exam, it'll look something like this on your page. Whereas on the back page, they'll give you this one. That's a good example. That right there, you have to be able to read the recursiveness and then figure out it's Newton's method. That's what you're learning. Yeah. So normally you don't have to do it, but for Newton's method, you just need to understand how it works, why does it work, and then you can then apply it. Now, as you're sort of seeing how I'm doing it, couple of things to note. Newton's method, when doesn't it work? There are 2 points when it doesn't work. It doesn't work if the tangent line ends up being parallel, because you just oscillate between the two. The two gradients. Every time you find the x-intercept, it gives you another tangent line, gives you the same x-axis intercept, gives you another tangent line, and it just goes back and forth. So you can get one where the tangent, the x-coordinate, the x-axis intercept gives you a new tangent line, that gives you the same x-axis going back and forth. So you have a oscillating sequence. Thanks, team. Just last one. Newton's method on your last page tells you some of your limitations to it. Number 2 is that if the stationary point is static, so once it finishes, it just finishes there. It doesn't actually go anymore, so you can't go further. So there's 2 scenarios that might happen. Okay? What are you going to get tested on the exam? On the exam, you're likely to get something like this one. We'll talk about that sort of later on when we get to pseudocode. but that's the kind of question that you would get related to Newton's method. Otherwise, you just need to understand the gist of how it works. You don't need to do the whole repetitiveness that I was just doing. But you do need to know how to do that on your CAS. So if you were to do a couple of iterations, how would you do on your CAS? I've given you guys a direction on this page here to help you do it on your CAS. If you don't know how to do Newton's method, just iteratively on your CAS. So on the back, you can follow the instructions there, and it guides you on how to make a spreadsheet. Okay, so I made a spreadsheet just to get there. Okay? I'm mindful of time. You guys got about 27 minutes left. I'm going to leave that to you. So today's two things: family of curves and Newton's method. Okay? It's not